All right, today we're going to be doing lesson 10.7 and 10.8. But we're going to start off with lesson 10.7, which is factoring special products. All that means is we're just going to be doing factoring just like we did on the earlier sections of chapter 10. When you factor, your answer will always end up as two parentheses. Sometimes it would be like x plus 2, x minus 8. Sometimes there may be different numbers, but that's what your answer will always end up, okay? These type of problems that we're going to be factoring are called the difference of two squares. Now, that's just basically their fancy name. Like, that's what you would see whenever you're doing your homework as the instruction, factor the difference of two squares, or maybe on your quiz or your test, factor the difference of two squares. But basically, what you need to hear most is that you are factoring, and you'll understand why it says two squares in just a minute. All right? The problems like we factored in the last sections that we just had a test over looked something like this. They had x squared plus 5x plus 6, or they looked like 2x squared plus 11x plus 5. Okay? They had an A, B, and a C. All right? Now look at these problems that we're going to be factoring today. This problem compared to these problems, what is this first one here missing? A B, a middle term, because C is always the number that does not have a variable, so it's missing this middle term right here. And the reason why is that middle term will cancel out, and you'll see what that means in a second. But where the name difference of two squares comes in is I look at each of these terms. Normally, when you're factoring the difference of two squares, or in order for it to be the difference of two squares, every single term has to have an exact square root. All right, so let's look. What's the square root of m squared? M. What's the square root of 4? 2. So I know this is definitely the difference of two squares. So what I'm going to do is this is very simple. This is exactly how you write your answer. I have my two parentheses, and what goes in the first spot in each parentheses is the square root of m squared, which is m. So we put m at the beginning of each set of parentheses. Now, what's the square root of 4? 2. So 2 goes at the end of each set of parentheses. All right, so now I've got to figure out what signs I need. Whenever C is a negative number, what do my signs always have to be? One positive, one negative. So I can put my plus and my minus signs. And if you wanted to, you could put m minus 2, m plus 2. It does not matter the order, as long as one is minus and one is plus. That's your final answer. Now let me show you, if we were to FOIL this to check it, how it's going to end up to be m squared minus 4. What you do is first, which is m times m, which is m squared. Outer, m times negative 2, which is negative 2m. Inner, 2m. And last, negative 4. Look what happens here. What's negative 2 plus 2? 0. So they cancel out, and I'm left with m squared minus 4. The whole point of these being plus and minus is so that middle term will cancel out. What a lot of people want to do is they see m squared minus 4, so they think both of these need to be negative, which is totally incorrect. That middle term will not cancel out if they are both negative. So that's why one's got to be plus and one's got to be minus. Okay? Let's look at this next problem. X squared minus y squared. Okay? You say, this one looks a little bit different. Okay? But let's ask ourselves, what's the square root of x squared? X. What's the square root of y squared? Y. So I can do it. So let's put my two parentheses. So I put the square root of x squared, which is x, which goes in the front. The square root of y squared, which is y, and it goes in the back. What do my signs have to be? Plus and minus. Final answer.
Can we put like the minus on the left side and plus?
Yes. If you want to do minus plus, that's fine. All right, let's do this next one. Okay, this one's a little bit different because the number is first, but the letter is second. But that does not matter. As long as they both have an exact square root, I can do it. But what's important is when I do it like this, What's the square root of 25?
5.
Whatever that first term is, that square root has to go at the beginning of those parentheses. You cannot say, okay, but I just like to write the letters first, so I want to write Q first. No, that cannot happen, or your answer will not turn out correctly. Okay? What's the square root of Q squared? Q. And I put a plus and a minus. And this is my final answer. Okay? And last one. Now this one I've got a number in front of the Q squared. Okay? Well, let's ask ourselves, does 9 have an exact square root? Yes. Does Q have an exact square root?
Yeah.
Does 64 have an exact square root? Then we can do it. All right, what's the square root of 9? 3. So I put the 3's. What's the square root of Q? I'm sorry, Q squared, Q. Now, look right here. We did not put the 3 at the front and the Q at the back because those are together in this first term. So they've got to be together as the first term in each set of parentheses. All right? Square root of 64 is 8 and a plus and a minus. Or you can put minus plus. It does not matter. Okay? All right, I want you to work on these next problems on your own, and then we will answer them. All right, let's find the answers to these problems. Jake, what is the answer to the first problem?
Uh, 2y plus 7, 2y minus 7.
Oh, the first problem, x squared minus 16.
X plus 1, x minus.
Very good. X plus 4, x minus 4. Noah, what is the answer to my second problem?
2y plus 7, 2y minus 7.
Very good. 2y plus 7, 2y minus 7. All right. Caroline, what is the answer to my third problem? D plus C and D minus C. Very good. And lastly, Sydney, what is the answer to my last problem?
8x plus 12, 8s minus 12.
Very good. 8s plus 12, 8s minus 12. Okay? That is the difference of two squares. Now, someone brought up a good question. They said, will it ever work out if I have x squared plus 16? If there's ever a positive in between there? No. It will not work out. The reason why, it's the difference of two squares. In order for these to cancel out, it has got to be a minus sign there. Okay? All right, now we're going to move on to 10.8. Again, we are still going to be working with factoring because basically all of Chapter 10 is factoring. We're not getting away from it. And this is the last lesson in Chapter 10. Okay? Now, two of these examples that we're going to do in Chapter 10, you already have been taught to do. You may just not have realized it. So the first example is called factor by grouping. Now, to some of you, that may be familiar because when we were doing our factoring, we would use factor by grouping at the end whenever I had a number in front of x squared. So let's say I had a problem like 2x squared plus 11x plus 5. Remember when we did these? This was from 10.6. Okay? We would do a times c, which is 10. List the factors of 10. All right, and we've got 1 times 10 and 2 times 5, and I would choose 1 and 10. All right, then we rewrite our problem. 2x squared plus 1x plus 10x plus 5. Then what we did from this step until the very final step is called factoring by grouping. So basically, all you're going to be doing in this problem and this problem is from this step on. They've already given you the 4 factors, okay? So let's go ahead and do that. So let's say that we've got our 4 factors. What would you do first in factoring by grouping? Anybody remember? Put parentheses. Very good. Parentheses around the first 2 terms and parentheses around the next 2 terms. Now what we do is we take out the greatest common factor of each set of parentheses. What is the greatest common factor of x cubed plus x squared?
2.
How many x's?
It's a 2x.
There's going to be 2 x's, so I write it as x squared. The reason why is this first term has 3 and this second term has 2. So the maximum that each of them can give is 2 because x squared could not give any more. And I realize that the numbers are 1 and 2, so the greatest common factor for the number would be 1, which I don't need to write. So let's rewrite what's inside of parentheses without that x squared. All right, if I had 3 x's and I took 2 of them out, how many am I left with? 1. All right, I leave my 2 in there because I didn't do anything to the numbers. If I had 2 x's and I took 2 out, how many am I left with? None, because there's none left. 2 minus 2 is 0. All right, let's look at this second term. 3x plus 6, what is the greatest common factor of that? 3. And because this sign right here is a positive, I put a plus 3 on the outside. Can I take out an x of either of those terms? No, because 6 does not have an x. So I'm going to rewrite this as 3 divided by 3 is 1x. Or if I wanted to, I wouldn't have to write that 1. Either way. 6 divided by 3 is 2. Did I get the same thing inside of these parentheses? Yes, I did. The only difference is one of them has a 1 in front of it and one of them is not written. So it is the exact same thing. All right, to write my final answer, I would group the outside terms together, which are x squared plus 3, and then the inside terms, x plus 2. And this is my final answer for factor by grouping.
So it's the same thing as the next one?
Exact same thing. All right, let's do the next one. Put parentheses around my first 2 terms, my last 2 terms. Ryan, what is the greatest common factor of x cubed plus 2x squared? X, how many of them? 2. Very good. So I can take out an x squared. That's going to make this first term x and this last term 2. All right. What is the greatest common factor of negative 36x and negative 72x? What kind of 36? It has to be a negative because anytime the very first term is negative in your group, you have to take out a negative greatest common factor. So I take out negative 36. Negative 36 divided by negative 36 is positive 1 or positive x. I can just write it like that. Negative 72 divided by negative 36 is positive 2. So then I write my final answer. X squared minus 36 and x plus 2. Okay. Does anybody recognize this from the lesson that we just did? X squared minus 36. Could I factor that even farther? Yep, I could because what's the square root of x squared? X. What's the square root of 36? 6. So I can make it x plus 6, x minus 6. Now you don't have to, but I want you to get used to being able to recognize when you're going to be able to. Okay? All right, let's do the next problem. Finding the greatest common factor. Again, you guys know how to do the greatest common factor. That's what we do in factor by grouping. We say, okay, what's the greatest common factor? So that's all we're doing here is taking out the greatest common factor of these terms. So if I've got 14x cubed and 21x squared, what is the greatest common factor of 14 and 21, Noah? 7. So I pull the 7 out here. All right, now I've got x cubed and x squared. So how many x's can I take out? 2. So I write x squared. Now remember, when you take out that greatest common factor, it has to go on the outside. Don't write it and rewrite your answer because then that's going to be wrong. All right, 14 divided by 7 is 2. If I had 3 x's and I took 2 out, I'm left with 1. 21 divided by 7 is 3. I keep that negative sign. If I had 2 x's and I took 2 out, how many am I left with? None. This is my final answer because all I had to do was take out the greatest common factor. All right, what is the greatest common factor of 11 and 22? 11.
Yeah.
Can I take out an x of either one? No, because 22 does not have an x. So now I just divide. 11 divided by 11 is 1. I leave the x there. 22 divided by 11 is 2. Final answer. Now on this third problem, I've got 3 terms. But that still doesn't matter. I can still take out a greatest common factor. So I look at all 3 of these numbers, 6, 12, and 18. Now my greatest common factor has to be something that can go into all 3 of them. So I look, what's the biggest number that can go into all 3 of them? 6. Very good. So I pull the 6 on the outside. Now let's look at variables. X squared, x, and then 18 does not have an x. So can I pull an x out? No. Every single one of them have to have an x in order to pull one of them out. And 18 does not. So I cannot take an x out. It can't give something it does not have. So now I just divide. 6 divided by 6 is 1, and I leave it x squared. 12 divided by 6 is 2, and I leave it x. 18 divided by 6 is 3. Final answer. All right, this very last example here is called factor completely. What factor completely means is that I need to check and see once I take out the greatest common factor, because that's always your first step, is to take out the greatest common factor. Once I take out the greatest common factor, what I have left in parentheses, can I factor it even farther? Okay, so that's what we're going to ask ourselves when we get down to that point. So step 1 is always take out the greatest common factor. So let's look. 4, 20, and 24. What is the greatest common factor of those numbers? 4. Now let's look at their variables. X cubed, x squared, and x. This time, can I take an x out? Yes, I can, because they all 3 have one. Okay, this one's got 3, the second one's got 2, the last one's got 1. So the maximum I can take out is 1. All right? So let's rewrite this, what's in parentheses. 4 divided by 4 is 1. If I had 3 x's and I took 1 out, I'm left with 2. So I leave it as x squared. You don't have to write the 1. Again, you can if you want to. 20 divided by 4 is 5. If I had 2 x's and I took 1 out, I'm left with 1. 24 divided by 4 is 6. If I had 1 x and I took it out, I'm left with none. Now, once you take out the greatest common factor, you are done with that. That does not come into play anymore. It just kind of hangs out until the very end, and it will be written in your final answer. But you don't have to do anything with it. Now my focus is right here on what is inside of parentheses. Can I factor x squared plus 5x plus 6? Yes, I can. Because look, I can list the factors of 6, which are 1 times 6, 2 times 3. I look and I see that 6 is positive, so which ones are going to add to give me 5? 2 and 3. Okay, so I'm just going to write that 4x because it's just got to stay there, and I'm going to factor what's left inside of parentheses. What goes at the beginning of each parentheses? X. The end is 2 and 3. And then since 6 is a positive, I know my signs have either got to be plus, plus, or minus, minus. So I look to B's sign, and it's a plus, so I know my signs are plus, plus. Now, this is my final answer. Okay? I have factored it completely. I've taken out the greatest common factor, and then I checked in my parentheses and said, yes, that can still be factored, so I have to do another step. All right, let's do this last one. 45 and 20. What's the greatest common factor, Sydney? 5. This one has x to the 4th, and this one has x squared. So how many x's can I take out, Noah? 2. Very good. So I write x squared. Now I need to rewrite what's in parentheses. 45 divided by 5 is 9. x to the 4th, and I took 2 x's out, so how many do I have left? X squared. All right? 20 divided by 5 is 4. If I had 2 x's and I took 2 out, I don't have any left. Now that I've got my greatest common factor, I focus right here. Can I factor 9x squared minus 4? Yes, I sure can, because it's the difference of 2 squares. What's the square root of 9? 3. Square root of x squared? X. Square root of 4? 2. Is it a difference? Yes, it is, so I can do that. So again, I just write my greatest common factor out to this side. Don't forget, you've got to include that greatest common factor in your answer. If you don't, it's going to be wrong. So square root of 9 we said was 3. Square root of x squared was x. Square root of 4 was 2. And I know my signs here have to be what? Plus and minus. Now I've got my final answer. Okay? Does anybody have any questions over 10.7 and 10.8?